Hello everyone. Today we'll be discussing the last topic of this chapter, and today's topic is called least common multiple, or which we commonly known as LCM. So what is this least common multiple? Now all these three words gives us some idea about what is actually LCM. It is the least, also it is the common, and it is the multiple. So let us first see the definition. The least common multiple, or LCM, of two or more given numbers is the smallest multiple of each of the given numbers. Now we know what is multiples. We have already learned or discussed about it in our earlier slides at the beginning of this chapter. So among those multiples, first of all we have to see which is the common multiples, and among those common multiples which is the least. That will give us the LCM. Now finding out the LCM, there are different methods that is given in your book. So first of all we'll be going through the general method, or which is the, you can say, the common method that is generally used for finding out LCM. So that method is the general method. Say for example, we have to find the LCM of 4 and 6. So how to do that? So this is the solution. First of all, we have found out the multiples of 4. Then we have found out the multiples of 6. So these are the multiples of 4, 8, 12, 16, 20, 24, 28, and then dotted. So why I have given dotted? Because as you know, in the you can say that in the rules of multiples, we know that, or it would not be appropriate to say rules, but we know that the multiples are infinite in number. I have already come to know about this beforehand. So these multiples are infinite in number. They are not finite or limited. So that's why we denote them by the dotted lines. Now among these multiples, if you see carefully, which are the common multiples? 12 is common in both 4 and 6, then 24, and then dotted. There may be more common multiples, but that is not our thing to see. What we need to see is that among those multiples, which is the least common? Yes, you're right. The least common is 12. Whichever comes the first, that is obviously the least. So that is the least common multiple. So this is one of the easiest method where this LCM can be found out. I hope you all have understood how to find this LCM by using the general method. Now next one is what is known as the prime factorization method. This is also given in your textbook. So say you have to find the LCM of 12 and 18. So what to do here? So as the name suggests, prime factors. So first of all we have to find the prime factors of the numbers. So the prime factors of 12 are 2 into 2 into 3, and 18 are 2 into 3 into 3. Now among this, what we have to see is that the LCM in the prime factorization method is the product of the prime numbers counted the maximum number of times they occur in any number. The maximum number of times. Now I know this sentence is not much clear to you, so let me make it a little bit simple. If you see carefully, in 12, which are the factors that are repeating here? 2, and in 18, 3. So these are the factors that are repeating the most number of times. That is what is said, the maximum number of times they occur in any number. So that means how many times they are repeated. Which one is repeated in the maximum? That we will take into consideration. So here in 12 also, this 2 has repeated twice, so we'll take this thing here. And again in 18, this 3 has repeated twice, so we'll take it here, and then we'll take their product. So whatever is the product, that will give us the LCM. So here the product is 36, 2 into 2 4, and 3 into 3 9. So 4 into 9 36. So this 36 is the LCM of 12 and 18. So this is also one of the easiest method, you can say. Yes, but you have to be first sure which factors are repeating the maximum number of times, or which has occurred most number of times. Now moving on to the third. Okay, this is also the same thing, prime factorization, but here you can see the prime factorization is done for 3 numbers. In the earlier case we have seen for 2 numbers, now we will see for 3 numbers. So nothing much difference, the same thing. Here also we have written all the factors of 40, 48 and 45. Then which has repeated the most number of times? Here the 2 has repeated. In 48 also the same thing. And in 45, 3. And 5 we have taken. Now, one more thing, if you see carefully, when we take the repetition thing, we don't take the same number. Just you have to see where that number has occurred the maximum. This 2 has occurred maximum in 48. 1, 2, 3, 4. 4 times. So we'll take this into consideration. Then 18, sorry, not 18. 3, where has 3 occurred most number of times? 3 has occurred here twice, so that will take into consideration. Then where is 5 occurred? 5 has occurred once, so it's the same thing. So we will take only once, 5. Then we'll do all the product. So that gives us the LCM of 40, 48 and 45. Clear? Now moving on to the last and the third method, that is the short division method. So as the name suggests, division. So here division will be done of all the 3 numbers. So let us see how it is done. So this is the division. See carefully, we have taken the 3 numbers. I'll stretch a line here. First we'll divide by 2. While dividing, we have to divide by such a number which is common, which can commonly divide all the 3 numbers or all the numbers. Say it be 3 or 2 or 4, how many numbers it is, no matter. But whenever we divide, we have to divide with such a number so that it is all these numbers are divisible. And mostly we take, or generally we take, a prime number, because most of the cases a prime number divides all that numbers. So this 2 is also a prime number, so we divided 2. So 20, it goes 10, 25. Okay, now in this case, here it's not divisible. So as I said, we take such a number. Just now I said we take such a number which divides all. But yes, in some cases it may occur that it may not divide. Then what to do? Then we'll keep that number as it is. Like in this case 25. We'll keep it as it is. No need to do anything with that. We'll keep as it is. But yes, 30 is divisible, so we'll divide. Then with 2. So why we have taken 2 here? Because it divides 20, it divides 30. So we have taken 2. We could have taken 3, but 3 doesn't divide anything. Yes, now you might be thinking we might have taken 5 also. Yes, obviously we can take 5. But it will narrow us down very quickly. So here I have shown you both the cases where it is divisible as well as not divisible. So you might be thinking, yes, by 5 we can divide all the 3. Yes, obviously we can divide. But if you see carefully, here there is a pattern that has been followed. That is, first the small prime number, then little greater than that, and then greater than that. So this pattern is also followed. So okay, I hope you all understood this method. Then what to do? Nothing to do much. All the numbers which we have divided, this thing we have to just take the product of it, and that will give us the LCM. So for finding out the LCM, any of the methods you can use. It's given in your textbook as well. I would not say you that you prefer this method or that method, whichever you prefer. No matter what method you use, the LCM would be the same in all that cases. So whichever method you find the best, or whichever you have understood the best, I would prefer that method for you to follow. Now coming to the last section of today's topic, that is some facts about HCF and LCM. So these things are required for solving the word problems. So first is, two numbers are said to be co-prime if their HCF is 1. Obviously from the definition of co-prime we know that two numbers are co-prime when they have only 1 as their common factor. Since 1 is only their common factor, so obviously that is their HCF. So one example is given here. 3 and 4 are co-prime numbers. So what is common between them? Only 1. So obviously their HCF also is 1. Next, the LCM of two co-prime numbers is equal to their product. If you have to find the LCM of two co-prime numbers, then since nothing is common between them except 1, so here what we have to do is that for finding out the LCM, just we need to find their product. Say for example 3 and 4 are co-prime, so if we want to find the LCM, just do the product, 3 into 4. That will give us their LCM. Next one, if one number is a factor of the other number, then their HCF is smaller and their LCM is the larger number. Say for example 3 is a factor of 6. We know that. So if we want to find the HCF of 3 and 6, so obviously which number is less, that will be the HCF. So 3 is the less small number, you can say, smaller than 6. So 3 is the HCF. And if you have to find LCM, the larger number or the greater number, that is 6 here. Here is 6. So that will be the LCM. So this is very simple. Now next, the product of two given numbers is equal to the product of their HCF and LCM. Yes, if you have to find the product of two given numbers, any two numbers, then what we need to do is that nothing we need to do. We just have to find the product of their HCF and LCM. If we know their HCF and LCM, then easily we can find out the product of the two numbers. This you can say the formula for this is LCM of any two given numbers is equal to first number into second number divided by HCF of the given number. So if we take this thing on the left hand side, it will be LCM of the two given numbers into HCF of the two given numbers, and that will give us the product of the two numbers. Here the formula is written in a little bit different way, but ultimately it gives us what is written in this statement. So I hope you all have understood this chapter as well as today's topic. So you can again go through your textbook. There are various examples. You can try it out for yourself. You can use any of the method which you prefer the best for solving LCM. So that's it then for today. Thank you and have a nice day.